here. We'll talk about it as we go. Now, this type of problem, for it to work out nicely, the radicand needs to be a perfect square. And if you take a look at this well-known identity, a plus b quantity squared is equal to a squared plus 2ab plus b squared, there's absolutely no choice right here but for a to take on the value of 11. Okay, so let's write that down. So we have 11 plus root 8 quantity squared. 11 plus root 8 quantity squared. And you can see the value of the 2 in that identity. 2 times 11 is 22. Okay, 2 times 11 is 22. So we get a perfect square. And when you take the square root of a square, you get the object without the square. They're inverse operations. And so what we get right over here would be 13 over the square root of a thing squared is just the thing, right? And so we get 113, okay, over 11 plus root 8. Now, y'all, a word on this problem. Why are we even doing it this way? You could try to substitute this in directly, but good luck with that. So we're trying to do another approach here, another approach that might be a little more manageable. Okay. Now, y'all, a very, very standard technique here is to multiply through by 1 in kind of a clever way. So let's try what we call the conjugate here. The conjugate surd, I've heard it called. Okay, we're going to multiply top and bottom by the conjugate of the denominator. You know, I think it's a good idea to put the parentheses. Sometimes things are dangling in space and you don't know what's going on really. So just to guide the computation, you're better off using the parentheses here. Okay, now, a lot of nice things happen here, it turns out. What you have in the denominator, well, let's just recopy the numerator at this point. We have 113 times 11 minus root 8. That's just juxtaposing those two symbols, or those two expressions. Now, what we get right here, y'all, is the classic difference of two squares formula. 11 squared is 121. The square root of 8 squared is 8, so you get 121 minus 8. But guess what? That's 113. And again, folks, that is the difference of two squares. A plus b, this is a plus b. A minus b gives you a squared minus b squared. But a squared is 121, b squared is 8. 121 minus 8 is the 113 that you see right here. So you see, that's good news in a sense, because this actually ends up being a fairly nice expression to work with. The 113s cancel, and we just get 11 minus root 8. Okay, 11 minus root 8. So after all of I mean, this nasty looking nested expression is actually just equal to 11 minus root 8. Okay, now let's keep going here. So what we can conclude right here, and again, this looks a little contrived, and I agree. I mean, I know what you mean. It looks like, how did you know to do this? Well, I've seen these kind of problems before. Okay, but if you subtract 11 from x, that's the same as subtracting 7 from this object, which it's equal to. And so that equals to a minus root 8. Okay. Now let's take a look at how we might proceed here. If you take a look, we're supposed to evaluate this expression that has a squared term in it, right? So it would follow that squaring this object right here might be a good idea. Okay, and when we do that, when we actually square this, trying to get this square, I'm trying to get some space here, folks. So this would imply that x minus 11 quantity squared is actually just equal to 8, right? When you square the minus sign, of course, you get 8. All right, now you see, believe it or not, we're in wonderful shape here. Now, I hope the motivation was good for you there, because we were trying to evaluate the squared expression. Okay, but if you'll notice now, it gets even nicer. If you'll take a look right here, and let me just write this right above. What is x minus 11 quantity squared is also the same thing as x squared. Just using that same result with the minus sign, minus 22x, which you see there. The 11 happens twice, right? And then plus 121, right? And this nice, you see, you can see it unfolding. It's really kind of a cool problem. So that means that this would equal to x minus 11 quantity squared. Okay, but we know that's equal to 8, and so x minus 11 quantity squared is equal to 8, but it's also equal to this. So we have to add what to get? So we have to add what to this? We have to add 6, right? Plus 6. Yeah, I hope that makes sense for it to equal this. You see, you would have x squared minus 22x plus 121 is part of this, right? So you have to add 6 to that to get 127, okay? And so anyway, that is going to finish the problem, because this would be equal to 8 plus 6. And so we get 14 is our final answer, folks. 8 plus 6 equals 14 is the answer. And I hope you like that. I think it's kind of some neat algebra. Now, I will say that it's set up to work. If this thing wasn't a perfect square to begin with, if this denominator, if this given information didn't work out so nicely, it would be a tougher road. But as long as you can rewrite this as a perfect square, the algebra works out very nicely. And of course, our final answer in this particular case worked out to be 14. Hope you enjoyed.